Hello, I'm Wen-Nung Lie from Department of EE, National Chung Cheng University CCU in Taiwan. Now I would like to introduce myself, my lab, and my research. Actually, I was included in the world top 2% of scientists at 2020. This is a report made by a professor in the Stanford University of America about paper publication, paper citation, and anyway, in most of it in the on the paper achievement. Okay, and here is about my lab. Now I have 17 students. Seven master year one. Among them, there are one foreigner from Vienna. Year two master student, seven, and one from Vienna. And I have three PhD students, and two from Cambodia and one from Indonesia. And for my graduate student, they are all postgraduate level. I have 120 Taiwanese in the past 26 years. I have also six foreign students in the past 1.5 years, including one Iran, one Poland, one Indian, one Thailand, and two Cambodia. So this is a group photo for me and my students in the lab. In this Lunar New Year is 2022 Lunar New Year. And this is a dinner photo with for me and my Iran student and my Poland student, and this is my Indian student. Okay, here I would like to roughly introduce my research. It can be categorized into four areas. For example, the traditional image processing and computer vision, and 2D here, 2D, 3D robot arm vision system. Later we will have some demonstration about this robot arm vision system. Okay, and another one, this is also robot, but not robot, but a humanoid robot. This means that the robot just like a person, has a human shape. A humanoid robot system. I will introduce you about our robot later. And the largest one is about the deep learning and machine learning for many applications such as ADAS, Advanced Driver Assistance System, and the skeleton-based human behavior analysis, like to detect or to predict the human fall down or any other action. And the video surveillance and the LD carrying by visual sensors. This visual sensor just like by RGB camera or by thermal image. Deep reinforcement learning DRL. This is about robot navigation. For example, if we want the robot to move from a source to a destination, how to plan the path to have a path planning so that it will not have a collision. This is we use a deep learning approach for robot navigation. And object pose, head pose, vehicle pose estimation, and prediction for medicine drug interaction, that is called DDI, and adversary reaction, ADR. I think this is the one, the exception that this is not for the image or camera related application. This is for drug, okay? Medicine, not image, no image here. And the others are all for the image related application. Here I will show some demonstration. For example, the first one is about the 3D skeleton estimation based on a single RGB image. You can see this demonstration. So you can see this is RGB image, single image, and we can apply the deep learning to estimate the skeleton. So you can see the skeleton is very, very accurate. And actually, this is the 3D skeleton, not 2D. So you can see here is 3D. So this is from two side, maybe one from front view and the other from side view. So you can see actually this is 3D, not 2D. Okay, so we applied the deep learning approach on this topic. And the second one is better exit prediction based on PPA thermal array sensors. And you can see here what is a thermal pile. Thermal pile means a thermal image, but it has a very low resolution, like only 32 by 32. With a low resolution thermal image, you cannot recognize who he is. You cannot recognize who is, and actually want to use this kind of small sensor to monitor the elderly. When the elderly want to get off the bed, then we want to predict or detect. So you can see here. Actually, this work
We want
was
to
done
go a
by
step
my
further and actually prevent the accident before it happens.
Poland
One
students.
possible
You
application
can
is monitoring
see.
the elderly bad side.
Oh, okay, this
Most
elderly.
accidents
And
happen
this
when
elderly,
generations
she
struggle
wants to
to
get
keep
off
up.
the bed, but
We
we,
can
we
prevent
want to
falls if we detect
predict
patients'
when.
efforts to get out of
If
bed
we can
early enough
predict in
and
advance
inform the
by several
caregiver
seconds, we
just
can
as the
inform the
person getting off the
caregiver
bed.
to assist her so that
We can raise
she
the
will
alarm
not get
that
off,
informs the
get off,
caregiver that the
get fall
patient
down the
needs
bed.
aid in
Okay.
getting off the bed. So we predict that the
And you can see this is the thermal image.
with a regular
So
in
you
public
don't know who
places
he
such
is,
as
right?
hospitals
But actually you
raises
can see,
serious ethical issues and therefore is
I will show
prohibited.
you
That's why our
my
system
student.
uses a novel premise.
Oh yeah. This is my
You cannot recognize
Polish
a person
student,
in-game,
and
you
this
cannot
is
see the face,
his
and in fact,
thermal
shows the
image.
rough
You
outline
cannot
of the body,
recognize.
which means that
So this is privacy free, and we designed such a prediction system by deep learning also. And you can, this is a scenario. This is a bed, and we install 3 TPS sensors on the ceiling and watch. So you can see this is. Can you recognize that? Oh no, you cannot. But the system can. Okay, so you can see. We estimate the probability that she wants to get off. You can see. Okay. So the probability if exceeds the threshold, we would like to give an alarm to the caregiver. Yeah, this is not elderly, but a girl. But a girl. Okay. So in other cases, sure. Okay. We have also other cases. Okay, this is about the action prediction or action recognition.
Even if the
Okay.
action is sometimes not.
And the next one, I will show you some also application, visual interaction between robot and the human. So you can see this is a humanoid robot, and the robot can recognize the speech and also can recognize the skeleton or the shape of the girl, so that he can salute. This is a salute to have some interaction between the robot and the girl. Okay. And the second one is about the robot control for stack object, pick and place. What is a stack object? Stack object means that there are several objects stacked together one by one. And we want to use the robot to pick and then press. But now you need to recognize what is the toughest one and pick one by one from the top to the bottom. Okay, so you can see now we show you. Okay, so this is a stack object, and we have a stack object is here, and we have the camera here. The camera have to perform an image capturing and processing, then control the robot to pick it up, and the robot will choose the toughest one to pick it and press. Okay. And here is the second, another example about robot control for precision pick and press. Actually, there is small object here. There's small object here. It is inside a hole, and the robot wants to pick it and press here, and the hole here is more accurate. So if you need to align with the hole, otherwise you cannot put the object inside the hole. So, but because here there maybe have some errors, so position errors. So we need to the robot needs to pick the object, and here will be scanned by the camera. Here actually is a camera, and the camera can analyze by image processing what is the position error and compensate for the error. Then we can align and put accurately inside the hole. So you can see. So you can see it is a very accurate. It is very. It will be very accurate. Okay, so this now camera take a picture and do some image processing. Then it can accurately put inside the hole. Okay, this is for the robot arm control. And the final one is about the heart rate estimation based on the facial image sequence. We have one kind of camera. This camera contains RGB and near-infrared sensors. So you can see this is the Actually, this is RGB. This is near infrared, and we can analyze the image and to estimate the heart rate of the person. You know, the normal speed, bit rate of the heart is about 72. Okay, so this is the remote, not like the contact method, but this is the contact is a method. Okay, so this is roughly my research result. Sorry. Uh, Oh, yeah. Okay, next one. Okay, thanks for your attention. But if you want to know more detail about, for example, my research, or you want to study the PhD or master degree in our university, please contact me at this email address, or you can contact my student, my PhD student Anli and Wang Vesna. Both these two students, they are all from Cambodia, and their address is here. So finally, I thanks for your attention. Thank